Chapter 1, Section 2, Part 2 discusses density. Now, density is equivalent to mass divided by volume, or D equals M over V. So the units are generally going to be in grams per centimeter cubed or grams per milliliter. Sometimes you'll see them in kilograms per liter as well. And densities are going to be unique to every substance, so they can be used to help identify different materials from one another. Here's a sample density practice problem. It says silver's density is 10.5 grams per centimeter cubed. You have a bracelet with a mass of 199 grams and a volume of 20.5 centimeters cubed. Is the bracelet pure silver? Okay, so in this particular problem, we're dealing with density. We always begin calculations by writing out our equation, D equals M over V. Then we're going to plug in our known values. Well, we know from the problem that we have a mass of 199 grams, so that will go on top here. And our volume is 20.5 centimeters cubed, so that will be our volume down here on the bottom of our equation. Now, when you divide 199 grams by 20.5 centimeters cubed, you get 9.71 grams per centimeters cubed. Now, if we compare that to the density of silver, which was given in the problem as 10.5, we can see that this bracelet, therefore, is not going to be pure silver. It must be an alloy of some sort or a combination of metals. The types of problems you'll be expected to do will be similar to this. You might also be given density and volume and have to calculate mass, or mass and density and have to calculate volume, but you'll always be given two of the three variables. The next thing in this section are different types of properties that substances might have. Physical properties are things that can be measured without changing the actual nature of the chemical. So for instance, things like mass. You can put an object on a balance and get its mass without changing anything about it. Volume, density, color, texture, all of those would be physical properties. A physical change then will only affect those physical properties. So melting ice, okay, it's still going to be water, but if you go from a solid to a liquid state. So it's still H2O, but you've simply changed the state. That's going to be a physical change. Same type of situation with boiling water. You're going from a liquid to a gas, but it's still water. Chemical properties are only going to be observed when substances interact. So a chemical change will always produce something new. An example would be rust. It's a combination of iron and oxygen for a new compound of iron oxide. And with a chemical change will always come some sort of change in energy. So there will be either an exothermic reaction going on or an endothermic reaction going on. That green color that the Statue of Liberty have, that's a result of oxidation. That's copper oxidizing. So that is a chemical reaction that is happening. Some evidence that a chemical change could be occurring could be evolution of a gas, meaning maybe there's a smell being produced or your solution starts to bubble. The formation of a precipitate, which is abbreviated PPT. And a precipitate is just a solid. Perhaps you take two liquid solutions and when you combine them you end up with a solid. That solid is called a precipitate. The third thing that could be evidence that a chemical change is occurring is either heat being absorbed or released, the emission of light, or a color change. Now, with any of these, you have to be careful because you cannot tell 100% sure if a chemical reaction is occurring unless you test that new material in the lab. So you have to produce something new. Sometimes you might have a color change and it's not actually a chemical change. So these are just criteria that are evidence that a chemical change could be possibly happening, but to know for sure you do need to test that new material in the lab to make sure that it is something different than what you started with. Finally, this is just a little review of a couple examples of identifying properties. So the first situation here, the boiling point of ethyl alcohol is 78 degrees Celsius. Well, that boiling point is a physical property. It's describing something that's inherent about ethyl alcohol. Diamond is very hard. Okay, again, that's going to be a physical property. We didn't have to do anything to that diamond except touch it to know that it's very hard. The last one here says sugar ferments to form ethyl alcohol. Well, as soon as we see that to form and this new substance here, that's going to mean that this is a chemical property.